And it's with exactly one pair of opposite sides are parallel. I'm writing it kind of weird because we're going to do a glue in over on this side. So if you wrote it all the way across the page, you might need to rewrite it, or you'll have to glue in a little bit below, and that's okay. Okay, so what's kind of goofy about trapezoids actually is that I'm a part of this math group online, and depending on your textbook, some say a trapezoid is where it has one or both sides are parallel, and some textbooks say exactly one, meaning it can't be both. It's kind of goofy. So there's a lot of debate about it. I don't know the right answer. Today we're going to talk about it as exactly one pair of opposite sides are parallel. Okay? So this is not a parallelogram, which means that all those theorems that we learned and we were bringing over and over and over, get your notes out, are not going to apply to a trapezoid. They have like a completely different shape other than it does have four sides. So you can go ahead and cut apart that glue in. If you want to cut each one individually right now, you can. We'll glue them in separately in just a moment. And we're going to glue this one in first right up here. If you walked in late or you didn't get one for whatever reason, the TSQR. I think Abby needs one, Miss Sutter. Do you have one? Oh my gosh, I'm so sorry. Did you get that message from Adrian in the middle of period one? Glad that we had to spend math time doing that. I think that's fish marking. Alright, I'm going to be using some colored pencils as we go through this. Mostly I'm going to be using green, blue, red, and orange. I'm going to use dark green, blue, and then red and orange. If you want to use the same colors, you can. If you'd like to use other colors, that's fine too. I'm going to use dark green, light blue, orange, and red. Okay? So something that we know about this is this is going to be a lot of vocabulary here. So sorry, I should have printed some of this out for you, but I didn't. So we just kind of have to deal with it. My bad. All right. First up, we got a base. A trapezoid has two bases, and a base is one of the sides that is parallel, or one of the parallel sides. So there's exactly one set of parallel sides, and the base is one of the parallel sides. So it has two different bases. That could be classified. Thinking about reading that book, Miss Sutter? Are you thinking about reading that one? Alright, I'm going to use green for base. And first, I'm really into boxing these today. And not just highlighting them. If you want to highlight them or shade them in, you can. I don't know. For some reason, I'm just really not feeling like shading it in. I don't know why. I feel very strongly. Alright, in this trapezoid, sides are parallel. The top and the bottom, or the left and the right. Good, top and bottom. If we drew them on and on and on, would they ever intersect? No. So, these are going to be our bases. How do I show that two lines are parallel? Xavier always knows the answer. They're not congruent, so we don't want the little tick mark. We want parallel. Arrows, yeah. Little arrows in there. So we're going to name those bases here. What is one of those segments that we just kind of highlighted? SR is one base. And what is our other base? Oh. Are you sure you want to go TQ? You don't want to go QT and call me a cutie? Rude. Alright. Other than a base, the other thing we have is a leg. And again, when we say a leg singular, we're saying the one of the not parallel sides, or one of the non-parallel sides. Or one of the sides not parallel. There we go. One of the sides not parallel. Okay, and I'm going to use light blue for that leg. And I'm going to do this pretty consistently throughout our notes. So as we do more problems, I'm always going to use green for my base and blue for my leg, just so it's uniform. Your notes, you choose if you want to keep it the same colors. If you don't, that's okay. Alright, so which ones are our legs here? Which are the sides that... I'm sorry, let me say again. Which sides are going to intersect eventually if we kept drawing them? Good. QR and TS. If I kept drawing those on and on and on, where would they intersect? Where would they touch? Would it be above the trapezoid or below? Below, yeah. So we're kind of thinking if we kept going, they would touch below. Good. All right, let's name those legs. Somebody already said them. Somebody else give me those again. TS and QR. Beautiful. Alright, next up, we got base angles. Base angles are a pair of angles connected by a base. A pair of angles connected by a base. So I'm going to use green just to highlight that word base, or underline it, just so that I know when I'm looking at my picture, I'm looking at those green bases. So we want two angles that are at the end of a... So if I look at this top base, TQ, what are the two angles at the ends of TQ? T and Q. T and angle Q could be called our base angles. But there are two bases, so there's another pair we could have used instead. Or, what are the other two angles connected by a base? S and R. S and R. Good. You guys are crushing this. Kind of going fast. I feel like you guys are keeping up though. It's insane. Alright, there is one theorem about trapezoids that we need to know, so I'm not gonna, I don't know, I'm gonna just do a little dot to show that it's a theorem. I don't know.
I have a question. Are we going to have to write all this information for every single node?
No. That was a good question. Alright. Our theorem is that angles connected by a leg are supplementary. angles connected by a leg are supplementary? I'm going to use that blue for leg, just so I know that I'm going to be looking at these blue sides now. So which two angles would add up to 180 in this trapezoid? What are two angles that are connected by one of the legs? S and T, or T and S. So measure of angle S, angle T will equal, what does supplementary mean again? 180. Okay, and there's another pair that share a leg. And what pair is that?
R and Q.
R and Q. So, the reason why some people want to say a parallelogram works is because of this theorem that they want to think like, oh, consecutive angles are supplementary. But that's not always the case, because another consecutive angle would be like S and R, and we don't know if those ones are supplementary. It's not necessarily. It's only the ones that share a leg that are supplementary. Alright, I'm going to just do kind of this line across just a tiny bit, because we're going to do a more specific type of trapezoid. So this is kind of the standard trapezoid that everyone thinks of when they think of trapezoid. It's the shape of your tables. So we're going to glue this one in. It's the blank one. I'm going to do it with the small side on top, big side on bottom. So try and find that one if you already cut yours apart. Alright, we're going to be boring and just call this one trapezoid A, B, C, and D. This is the last one that has kind of some more things to write. Alright, in this trapezoid, which one are our bases? What two sides are the bases? What?
DCAB.
DC. I didn't hear the D. I thought you just said CAB, and I was like, what? D and A to B. Okay, if you want to throw in that arrow, you can. Parallel. B, C, and AD, or DA. Good. Alright, what we call this one? We call this one an isosceles trapezoid. We learned about that word isosceles last trimester. Does anyone remember what shape we learned isosceles with? Triangles, good. And what do we know about an isosceles triangle? Not all the sides, because that'd be equilateral. Two sides are the same. And sides of a triangle we call legs. Do you guys remember that? Like the leg of a triangle? So, with isosceles, it means that two legs are the same. And here, what did we say are the legs? What were the legs? AD is going to be congruent to the other leg, BC. So it's that the legs are congruent. because our legs are congruent, that creates a couple other properties that aren't in all trapezoids, but are specifically in this type of trapezoid, that isosceles trapezoid. So you guys said AD will be congruent to Alright, one of the things that happens when we have those legs that are congruent is that our base angles will be congruent. Okay, base angles. So our base angles, those pairs of angles, will be congruent to each other. So does anyone remember base angle means that they share a base. So what's one of our angles here, or two of our angles that share a base together, or that are connected by a base? Can't talk. Let's start with angle A. What angle is connected to A by a base? B. So these ones will be congruent in an isosceles triangle. Okay, but we have base angles, two angles that are connected by a different base. What are those angles connected by the other base? D and C. But these ones are congruent to each other. They're not congruent to the ones on top. So I'm going to use two swoops for that one. Give you time to mark that up if you need to. Use colored pencils if you want. A couple people still writing, so it'll just take a second. Alright. The last thing that we know about isosceles trapezoids are that now, our diagonals weren't drawn in this picture because we wanted to look at those angles a lot. So we have to kind of imagine those diagonals that would be drawn in. Remember, a diagonal cuts through the shape. So what is one of our diagonals if we were going to write it out? C to A, or AC, would be congruent to the other diagonal that would connect B and D. Alright, so that was kind of its own idea there. We're going to do a couple of angles with an isosceles trapezoid. If you have about 6 lines, I said 5 in the last class and then I panicked because I was running out of space. About 6 lines, you can probably fit it in. If you have less than 6 lines, you're going to have to squish it together or just go to the next page. Okay? We're going to glue in this R, Q, R, S, Q, T, R, S, T, Q. Q, R, S, T. There you go. Alphabetical. Alright, we're going to do 2 examples with this one. Before we do our examples, let's just color code our base and our legs. If you haven't gotten the hint yet, that's probably the biggest part about trapezoids, is figuring out what's are the base and which ones are the legs. So which ones are our base here?
QT or
QT, yes I am. And RS. So there's our parallel sides. And then what do we call the QR and ST? What are these sides called? Legs, good. And these legs, they say, are congruent. They do that. So not only it being a trapezoid, we know it's a isosceles trapezoid. So all the things for trapezoids still applies to this, and all the things from isosceles trapezoids apply to this. If QS is 17 centimeters, I want to know how much is RT. QS is 17 centimeters. How much is RT? So our first step would be to locate what parts of this trapezoid are these segments. So when we connect Q to S, that segment, is that a base, a leg, or a diagonal? A diagonal, good. What about RT? Is RT a base, a leg, or a diagonal? Diagonal. And what do we know about the 2 diagonals in an isosceles trapezoid? They're congruent. So RT is 17. If you're like, that was too easy, you're right. That was too easy. It's okay for some of these problems to be easy. Right? What I'm noticing is some people, like on the rectangles, they're like, well, if this side is 6, then that side's 6. And it's like, yeah, but that's too easy. It's okay. Your answers can be easy. Math can be easy sometimes. Amazing. All right, number 2. All right, if the measure of angle QRS is 115 degrees, measure of angle QRS is 115 degrees. I want to know what is the measure of angle RQT. No, I'm not asking are you a cutie. I want to know the angle RQT. No one even smiled, only Miss Swider. I'm hilarious, people. Next year, when you guys are sitting in Algebra 2, you're going to be like, dang, Miss Morrell was so funny. I wish I would have laughed at her jokes so that she knew how funny she was. Okay, alright. So, first thing we're going to do is locate these angles, QRS. Not the ABCs. Alright, Q to R to S. Where will the vertex of that angle be, the middle be? At the Q, the R, or the S? R, good. Because the R is in that middle, so Q, so it goes all the way from Q, R to S. Can anyone remember why do we have to name it QRS? Why couldn't I just say angle?
because angle R has 3 different angles inside of it.
Yeah, there's 3 different angles there. Nice. So we have this smaller angle, this smaller angle, and then that whole angle. So we need to make sure we're using 3 letters there. Nice job, Xavier. All right, and we're trying to find RQT. So RQ to T. It's that whole angle at Q. Are these 2 angles going to be congruent? No, so let's do 2 swoops there to show that they're not the same. We didn't have anything up here that connected those 2 in the isosceles trapezoid. Sometimes I just want to say triangle. So what do we know about angle R and angle Q? QRS and E. What do they share? A leg. And what do we talk about when we have 2 angles that are connected by? Yeah, they're supplementary. Is that specific to just this isosceles trapezoid? No, that's for all trapezoids, so we just have to remember that. So we know that these two are supplementary, which means what? They add to 180. So if I know that one is 15, how can I find the other one? Yep, I would subtract. 180 minus 115. Some people can just think in their head 115 plus what would make 180. And we get anyone? 65. Beautiful. Thanks, Jameer. So the measure of angle RQT, which you all are QTs, is 65. I got a sympathy laugh on that one. Somebody was like, we're not going to have her go on her rant about how funny she is again. I'll laugh at that one. All right, we do have one more thing about trapezoids when you come back from lunch about mid-segments. If you want to glue in that last one so you don't lose it, you can on the next page. We have more notes after lunch, so come back after lunch. We'll do that mid-segment, and then you'll get some time for practice.
What?
I'm using pink. Switching it up. Pink.
Oh, that was a bad word. Did you hear that?
No.
Oh.
Alright, mid-segment. A mid-segment is the line that connects the midpoints of each leg. Hey, you guys.
Everybody take a deep breath.
Alright, so the line that connects the midpoint. The line that connects the midpoints of each leg. So if VY is a mid-segment, that means we have two midpoints there. What's one of the midpoints? V, and the other midpoint would be Y. So if we have a midpoint, what do we know about the side then? They're the same. Layla. Bro. And then this side would also be the same, not necessarily the same as the other side, but as each other. Okay, and what we know about the mid-segment is that VY, that mid-segment, oh my gosh. But the most frustrating part is that this table right in front of me. Like, you guys are the closest to me, and it's too much. Alright. VY equals, we're going to add together the bases, FE plus CD, and divide by 2. So because it's a mid-segment in a trapezoid, it ends up being half the distance of the sum. It's the average. It's right between the bases. So if you want to write that in words, it's that the mid-segment is equal to the bases divided by 2. All right, last problem for today. We're going to do number 3.
I'm sorry.
All right, number 3, we know FE is 6. And CD is 18. I want to know how much is VY. Alright, so VY is that mid-segment. So we're going to take VY and say it's equal to our two bases added together divided by 2. What's one of our bases? FE, which is 6, plus, what's our other base? 18. Alright, now if we use our order of operations, are we going to add first or divide?
Add.
Normally we divide first. Why are we adding first this time?
It's in parentheses.
It's got it. 6 plus 18 is what? 24. Okay, so 24 divided by 2 is 12. Alright, here's the deal. We still haven't done kites yet. So far we've only done trapezoids. Kites is an easy peasy thing. But we're going to just wait and do that on Monday. We'll spend about 5 minutes of our day on Monday before the one-pager doing our kites. So, when you do your practice today, the very last question you won't know the answer to. And that's okay, because it's about a kite.
You want us to guess?
So, no. You're gonna start it, and they'll just finish it quick on Monday. Okay?